So today we are gonna solve this question number 7 from Holland Knight linear algebra. So let us start. Like, how do we think on seeing this type of questions, and how do we solve or tackle such problems? So the question says, prove that, and there is a complex LHS and there is a simplified RHS, and somehow we have to arrive from left hand side to right hand side. So first of all, let us see like what do we think on seeing such type of questions. So let us explore the thought processes that should come in one's mind, or that may come in solving such kind of or similar problems. So the concept that we learned in one of our previous problems, that divide numerator and denominator by a group of common variables, or we can extend that to say that take something common from both numerator and denominator respectively, so that we get a form on left hand side that is kind of simplified version, or an understandable version, so that it makes sense to somehow use this information which is given to us and substitute in that simplified expression, that is simplified version of this, to get somehow this. Okay, so the first, like one of the things that we can do is, why not take out something common, and something in this is most probably a guess, a4 and b4 from numerator and denominator respectively. So that, and why did we think like that? It's because the numerator and denominator on the right hand side is similar to a4 over b4. So when we do this, we get a4 over b4 multiplied by whole of this expression in numerator and this expression in denominator. And we know that if somehow we make this expression equals to 1, then our job is done, because we'll get to prove LHS equals to RHS. So how to make this? And to answer how, if we think, we see that we haven't used this information yet. So somehow use this, right, and arrive at right hand side. So if we want to simplify this expression on left hand side, we have to see and think about the coefficients. So let's watch the coefficients carefully, and we see that there is 2 in numerator, 2 in denominator, 3 in numerator, 3 in denominator, and minus 5 in numerator, minus 5 in denominator. So it becomes a kind of intuitive to conclude that if we somehow if we see the numeric coefficients, they are equal. Now seeing the algebraic coefficients, or the algebraic part, b square is same in numerator and denominator, but we somehow, if we prove e square over a square is equals to f square over b square, and we somehow prove that this e4f over a to the power 4 and f to the power 5 over b to the power 4, they are also equal to each other, like this. So then our job is done, and ultimately we'll get 1 on left hand side. So as we know, we haven't used this information yet, so we can replace this algebraic quantities by simplified version, like s1 equals to b square, s2 equals to e square over a square, s3 equals to e to the power 4 f over a to the power 4. S4 equals to f square over b square, and S5 equals to f5 over b to the power 4. So if we substitute these, we get this. And now, as I already said, if we make this S2 equals to S4 and S3 equals to S5, then we'll be able to prove what's being asked in this question. So to prove that, we know that we haven't used this, so let's use this given information. So the concept is basically, in order to get a simplified version on left hand side to arrive to the right hand side, so the two things that we learned, we build upon is, first of all, take something common, which we already did from numerator and denominator, and second is to use the given info, the very first information, the concept that we learned in question 1. So somehow when you are stuck in problems, you should see that if you have used the given info properly or not. So when you use it, you see that if you see S2 and S4, they are equal, because if you see from this arrow, e to the power f equals to a over b, right? So if we rearrange this, we get e over a equals to f over b, right? And if we take a square sides, we get e square over a square equals to f square over b square. So this job is done. We have proved S2 equals to S4. Now we have to prove S3 equals to S5, that is S3 equals to e to the power 4 f over a4 equals to f to the power 5 over b4. How do we do this? So f to the power 5 over b4 can be written as f dot f to the power 4 over b to the power 4, right? And again, so we see that something is common here again. So we have e to the power 4 and e to the power 4, and again f here. So we see that f is same, but this quantity e to the power 4 or a to the power 4 has to be somehow equals to f to the power 4 over b to the power 4, and then our job is done. Okay, so if we substitute this and this here, right, by raising both sides to the power 4, we see that our job is done, and we are able to prove S3 equals to S5. Thus we are able to prove that this numerator is equal to this denominator, and hence they cancel out to give 1. So hence we have proved our question which is being asked. Thanks.